Hello everyone. The article I chose to discuss in this journal club is entitled Bifidobacterium longum 1714 strain modulates brain activity of healthy volunteers during social stress. This article described the impact gut microbiota has on brain activity in situations of social stress. It's interesting to explore how to stimulate different areas of the brain and the consequences of this. This article answered whether B. longum 1714 in the gut can impact an individual's response to social stress. This study focused on brain activity and if taking a probiotic can lead to increased power in theta and alpha waves and decreased power in beta waves. Individuals who participated in this study were given either a probiotic containing the before-mentioned bacteria or a placebo. Individuals were then subjected to social stress by a virtual game of inclusion and exclusion called Cyberball Game, or CBG for short. After 4 weeks, their levels of social stress were measured again, and the individuals taking the probiotic had increased theta and alpha band power and improved stress responses. These findings will be discussed more later. However, these findings can prove to be extremely impactful in understanding the correlation between brain activity and the microbiota in our guts. It has long been hypothesized that the microbiota in our guts can impact our brain function. Over a century ago, Elie Metchnikoff believed that eating yogurt could delay the effects of aging. While his hypothesis was never validated scientifically, theories that our gut microbiota can have large impacts on other areas of the body continue to be explored. One article that explored this was the article by Wang. However, before this article was published, research on Bifidobacterium longum 1714 and the impact it has on stress levels in mice were researched. Stress in mice was measured through the use of hypothermia tests, marble burying, forced swim tests, among others. It was found that this strain of bacteria had an antidepressant-like effect on the mice being tested. Probiotics and the microbiome of an organism clearly have an impact on how the rest of the body functions, and more specifically, on how the brain functions. Because mice are impacted by this bacterium, curiosity on the impact that it can have on humans emerges, and the article by Wang explored this. Before the article by Wang was published, there was a gap in the available research. Research was not done thoroughly on the impact this bacterium has on human stress levels, nor were there any articles that specifically targeted social stress and its impact on that. As such, research had not been done on the bacterium's ability to modify brain function. The majority of research that had been done only focused on how the bacterium impacted mice and their stress levels, or acute levels of stress in humans. The studies that had been done on humans used probiotics with multiple strains of bacteria, making it difficult to determine what bacterial strain was responsible for the lowering of depression and anxiety. Wang bridged this gap and encountered meaningful discoveries on how our gut microbiota can directly impact brain function. As mentioned earlier, the article that I chose asked the question, to what extent does the presence of B. longum 1714 in the gut impact an individual's response to a situation of social stress? Furthermore, Wang mentioned how it had been shown that this bacterium has been shown to decrease cortisol output when individuals are exposed to an acute stressor. However, it was unknown if the bacterium is capable of modifying brain function in humans. Wang hypothesized that B. longum 1714 modifies resting brain activity and responses to social stress. It was predicted that the alpha and theta band power during CBG would be impacted by treatment with probiotics. Healthy adults were gathered for this study. The individuals who participated needed to be aged 18 to 50 years, non-smokers, have a BMI of 18 to 30, no allergies, willing to stop their use of probiotics, not having an immune-suppressing illness, not have taken antibiotics in the last 2 months, have no psychiatric or gastrointestinal disorder, and not have any non-removable metal parts in their body. The participating individuals were also given a list of prohibited foods, including yogurts containing probiotics, goat's milk, soy milk, and pickles. Additionally, participants were screened for IBS and psychiatric disorders. For this study, Wang utilized a randomized double-blind parallel group design. Individuals were randomly selected to either receive a probiotic or placebo for 4 weeks. The groups assigned were only revealed after the completion of the experiment and data analysis. Those who took the probiotic took 1 × 10⁹ colony-forming units of B. longum 1714 in 2 grams of maltodextrin. Those who took the placebo only took 2 grams of maltodextrin. The placebo and probiotics were identically packaged, and all participants were given the same instructions for taking their sample. 61 participants were evaluated for participation in this study. 18 were excluded due to not meeting the criteria or declining to participate, given 43 participants who were randomly put in either the probiotic or placebo group. The flowchart on the screen shows the process of selecting participants for this study. 3 participants from the probiotic group were not included in data analysis due to the use of antibiotics during the trial, giving 20 participants in the probiotic group and 20 participants in the placebo group. 7 men and 13 women were selected for both the probiotic group and placebo group. These groups were then divided equally among other demographics such as birth delivery, age, and BMI. Cyberball game, also referred to as CBG, was used to measure the effects of social stress. Participants were asked to play this game with 2 other virtual players. A screenshot of the game is shown on the screen. This game involves players passing a ball from one player to another by either clicking the right or left button. In one situation, the player was included and the ball was passed to them. In the other situation, the player was excluded and not passed to. After the game, individuals filled out the NTS, MQ, and SCP questionnaires to measure their levels of distress. This chart shows the demographics of participants as well as their baseline scores for SF36, NTS, MQ, and SCP. SF36 was a 36-question health survey administered before and after the initial testing. NTS signifies the need-threat scale, which was used to measure the emotional effects of being socially rejected. Higher scores in this category related to higher levels of distress. MQ is the mood questionnaire, which asks questions such as, "Are you feeling happy?" and "Are you feeling bad?" SCP was the subjective exclusion perception. This asked participants to rate the statements, "I was ignored" and "I was excluded," on how much they relate to them on a scale from 1 to 10. All of these scales measure the feelings of exclusion and social stress exhibited by the participants after playing the cyberball game. The results of those questionnaires are shown on the screen. Additionally, brain magnetic fields were measured using the MEG method. This allowed Wang to measure the alpha and theta band power and whether or not it changed during treatment with a probiotic. Analysis of this MEG data was then performed using MATLAB. In the baseline results, there was no difference in the stress levels across all individuals during a resting state. These tests were done before the individual played cyberball game, so this was to be expected as this was before the individuals were exposed to the situation of social stress. As a result, they should be fairly similar. Additionally, at the baseline level, there were no significant differences in the SF36 scores or CBG scores between the probiotic and placebo groups. There was a significant change in the brain activity when comparing scans from when the individuals played the inclusive situation and when they played the situation where they were excluded. Additionally, the levels of NTS and SCP were considerably higher, and MQ scores were lower in the condition where the individual was excluded compared to the one they were included in. This signifies higher levels of social stress and insecurity when the individuals played the condition where they were excluded. Additionally, Meg showed that the activity in certain brain regions behaves significantly different in the exclusionary situation compared to the inclusive one. These results showed that cyberball game was increasing levels of social stress in participants. This was crucial information as the majority of the experiment depended on this game provoking levels of social stress and anxiety in participants. This game caused individuals to feel left out and overall bad, thus allowing Wang to explore the impact that B. Longham 1714 had on the level of social stress exhibited by the participants. After 4 weeks of taking either the probiotics or the placebo, brain activity was measured again. Brain activity was measured using both a resting state before the individuals were subjected to social stress and while they were in the stressful situation. After 4 weeks of either taking probiotics or placebo, it was shown that there were significant differences in brain activity for the group taking probiotics compared to the group taking the placebo during the resting phase. Those in the B. Longham group saw an increase in theta band power in the bilateral, inferior, middle, and superior frontal cortex. That group also saw reduced beta-2 band power in the bilateral hippocampus, the left inferior, superior temporal, bilateral middle temporal cortex, and the left cerebellum. This image shows the difference in neural activity during a resting state. This image shows 3 different views of the brain and highlights the regions in which there is greater theta band power. The orange areas in the brain signify those regions in which there is increased power in theta bands. As you can see, there is increased power in clusters in regions including the bilateral inferior cortex and middle frontal cortex when comparing the group that took probiotics to the group that took the placebo. Increased theta band power is often associated with feelings of rest and relaxation. From this, it can be inferred that the probiotics cause an increase in activity in bands that are linked with relaxation, just like Wang hypothesized. This image shows the reduced beta-2 band power clustered around the hippocampus, left inferior and superior temporal cortex, bilateral middle temporal cortex, the left cerebellum. Once again, this image shows different views of the brain and highlights the regions in which there is decreased beta band power. Those regions in which there is decreased beta band activity are highlighted in blue. Decreasing beta bands is often associated with lower levels of stress. Another situation where these bands are lowered is through meditation. This displays the relaxing effect that B. Longham 1714 had on the brain. B. Longham 1714 resulted in lower levels of beta waves, which is a wave that high levels of is often associated with higher levels of stress. With regards to SF-36 scores, there was no significant differences found between the groups after the 4 weeks. In other words, there was little change in the subjective stress levels of participants who were taking probiotics compared to those taking the placebo. Nevertheless, this was not the goal of the study. The aim for this study was to observe the influence that probiotics have on brain activity, not subjective levels of stress. However, after further investigation, comparing brain scans and specific questions on SF-36, a relationship was found. This graph shows the relationship found between theta bands and reported energy from SF-36. In the graph, the change in theta band power is shown on the y-axis, and the subjective change in energy is shown on the x-axis. For all groups, there was a positive correlation between changes in the energy/vitality section of SF36 and changes in theta band power. This is shown in the figure on the screen. As you can see, there is a positive linear trend line showing the correlation between theta band power and the SF36 item. From this, we can infer that there is a relationship between energy and increased theta band power. Since we found that B. longum 1714 was associated with increased theta band power at resting state, we can conclude that taking probiotics can be connected to changes in theta band power, which can then be connected with increased energy. Furthermore, there was also a relationship found only in the probiotic group that correlated decreased power in beta-3 bands with increased energy and vitality. There was a significant negative correlation with beta-3 band power and the energy/vitality section of SF36. The changes in neural activity are shown on the y-axis, and the changes in energy are shown on the x-axis. The negative correlation between beta bands and energy is shown in orange, and decreased levels of beta bands are often linked to feeling more energy and less stressed, while an increase in beta band power is often associated with fatigue. This further supports the idea that B. longum 1714 influenced energy levels. While this effect was not initially hypothesized, the energizing effect of B. longum 1714 may lend itself to more exploration of probiotics and the effect that they can have on energy levels. The positive correlation between theta bands and energy is shown in blue on this graph. There also appears to be a stronger correlation between theta band power in the probiotic group than that compared to the entire group. However, the authors do not mention this increased correlation as significant, so more analysis would have to be done to see if this increased correlation is a significant finding. As mentioned earlier, brain activity was also measured while the individuals played cyberball game. Similarly to the tests done at resting state, there were also changes in brain activity for the probiotic group while playing cyberball game compared to the baseline. Moreover, it was shown that B. longum 1714 also altered brain activity during social stress produced by cyberball game, as measured by MEG. After the 4-week intervention, the individuals in the probiotic group showed increased theta band power in a cluster consisting of the right IFC and the bilateral MFC and SFC, the left AAC, the bilateral MMC, and the right supramarginal gyrus in both the inclusive and exclusive conditions. This is shown in the diagram by the highlighted orange regions of the brain. This diagram shows 3 different views of the brain, and each view highlights the regions in which the activity is increased. There was also increased alpha band power in clusters in the brain. Similarly to theta bands, alpha bands are also associated with increased levels of calm and relaxation. This diagram highlights the regions in which alpha band activity has increased. This diagram also highlights the regions in orange, but this time it highlighted those that experience more alpha band power than those that are not highlighted. This diagram also shows 3 different views of the brain. Regions of increased activity are highlighted in each of these views. It can be inferred from this that the brain of individuals taking probiotics on average had increased activity in brainwaves associated with feeling more relaxed during the cyberball game than those taking the placebo. Additionally, their brains also had more brainwaves associated with feelings of relaxation after taking the probiotics than they did at the baseline. This article fills the gap in the research on how B. longum 1714 can influence brain activity. Research has been done previously using multiple strains of bacteria in probiotics, but this study allowed information to be discovered on how this specific strain of bacteria can influence brain activity. This study showed that B. longum 1714 altered neural activities for participants during both a resting state and while in a situation of social stress. While a change in subjective levels of stress were not observed, this was not the goal of the study. The goal of the study was to observe changes in brain activity and wave power. We cannot say that B. longum 1714 influenced the stress levels in participants. However, we can say that B. longum 1714 activated waves in our brains often associated with feelings of relaxation. One limitation of this study was using the same stressful situation to measure levels of social stress. It was described by Wang that enduring the same stressful situation repeatedly, that the memory of previously experienced stress may make it difficult to discern stress from current or past experiences. This may have been exhibited in Cyberball game, as individuals may have been feeling stress from the first time the game was played. However, I do not see a way around this problem because using a different situation to measure stress after 4 weeks compared to the baseline would not be useful, because you would need to use the same situation for both baseline and after 4 weeks to have a meaningful comparison. Additionally, Cyberball game may not have been very applicable to daily life. The cause of social stress in adults is normally not from being excluded in a virtual game. Brain activity may be different in day-to-day scenarios where social stress is exhibited as compared to Cyberball. Another limitation was the small sample size. Only 40 people were used in this study, making it difficult to make generalizations about an entire population. One strength of this study was the use of control groups and baseline testing. This study measured the brain activity of participants multiple times. From this, it was ensured that there was data from when the participants were resting and when they were in stress and after. Wang and their colleagues were sure to have a good control sample and baseline for this study. Additionally, there were very clear guidelines on who could participate in the study. This helped to eliminate other variables that may have skewed the results of the study, such as the use of antibiotics. In the future, more research can be done on energy levels and how probiotics can influence levels of energy in participants. This was only briefly touched on in this study, but I believe that there is a lot more research that can be done on probiotics' ability to influence energy levels. Additionally, more of the questions on SF36 can be explored to see if there was any kind of correlation between brainwaves and another question on SF36. I learned a lot from this article. Since reading the article describing Ellie Metchnikoff's theory on probiotics and delaying aging, I was interested on how probiotics can influence the brain. This was a concept I had never heard of, and I thought that it was interesting to further explore. I thought it was also interesting to see just how interconnected the body is, and I believe that this article enhanced my understanding of this. Our guts can influence other areas in our bodies, like the brain, and I really enjoyed learning of this. My discussion questions that I propose are: do you think there are strains of bacterium that can impact subjective levels of stress in participants? Why or why not? And can you think of any other ways social stress could have been measured that would have been more applicable to daily life? How do you think the inclusion of results from the individuals who needed to take antibiotics during the study would have impacted the results? In other words, if data from those individuals was analyzed instead of being left out, what would have happened to the results of this study? Do you think the use of probiotics can influence activity in any other areas of the body other than the brain and gut? And overall, what was your main takeaway from this article? And here I have my references. But in general, the microbiome in our bodies plays a pivotal role in how the rest of the body functions, and this article showcased this and opens the door to more scientific discoveries relating the gut to the brain. Thank you.